Hi. So we are going to share a quite interesting lesson, a quite interesting lecture. And it's going to seem that we're talking about cars, but we are not talking about cars, okay? So let's think about this moment in which you finally take the decision of buying a car. You go to the dealer, and this is this magical moment. You're looking at very different cars, one from another, until you make your choice. And after you make this choice, you think you have already taken an important decision, but there is one that is even more important, and that is financing. How much is your down payment? How much is the value of the loan? And all of these procedures that they have until you can finally drive that car that you just bought or that you were planning to buy. So whenever you want to know how much is going to be, finally you decide how much you have for the down payment. You want to know how much you're going to pay every month as part of this financing, as part of this of your loan. And you will sit in a desk, and somebody will start making these strange numbers and will give you this final number, which is your monthly payment. So let's exclude everything related to insurances or other technicalities that will be included in your monthly payment, and let's just be concerned about the pure concept of this financing, about the principle or about the money that you owe to the bank when you're buying that car, and what is the portion of this loan that you're going to be paying on a monthly basis. So this is basically your base monthly payment. Of course, on top of that monthly payment, you will have other fees, and other technicalities will just increase this monthly payment. But let's focus on the loan and how you can calculate your payment. Okay? So we have already learned about ordinary annuities, annuity dues, perpetuities, present value, future value. So what are we doing here? We just know that we are going to receive an amount from the bank in order to buy the car. And we want to know what is going to be the monthly payment. So in this case, we're going to make a couple of assumptions to make this exercise simpler. And the first assumption is that the loan amount that you're going to take is just $10,000. So you will find, or you found a car for which you only need $10,000 in loan. Then the period of a loan is going to be 5 years. And for simplicity, we're going to have annual payments. Otherwise, it would be very difficult to have a table like this and maybe 36 months shown here and calculate each one. You would probably stop watching the video. And then we have an APR, which is the annual percent rate, which is going to be 10%. Now, how do we calculate this payment that we are going to have, which is going to be our commitment with the bank or with the car dealer every year in this case? The first thing we learned is we already know how to get the PV. So let's make a couple of adjustments. Let's, before making those adjustments, just plug all of the values that we already have in our formula. So the first value we have is the PV. So the present value in this case will be the amount that the bank or the car dealer is going to lend you, because that money, you're receiving it today, and then you're immediately investing it in the car, right? So the PV is going to be 10,000 because that's the amount of the loan. So we have this, we're plugging it in our formula. And then we will have cash flow. So cash flow is, and if we do the timeline, let's do this timeline here. So if we do the timeline, I hope this is a good place to do the timeline. We will have year 0, year 5. Summarizing what we're trying to do here, we're getting a positive amount of $10,000. And then we will have 1, 2, 3, 4, 5 payments, because we are assuming annual payments. And we're assuming a period of 5 years to cancel this loan or to completely pay it back. So we are not sure. We know what future value is. It should be 0. Because when we reach the 5th year, when we reach the end of the 5th year, our balance of this loan should be 0 because we need to pay the entire amount by that time. Now, the bank or the dealer will charge us with an interest rate, which we're assuming is going to be, or let's use in order to keep consistency with our previous formulas, let's say it's I, and the interest rate, we're assuming it's 10%. And what we want to find in this example is how much our payments. Okay? If we were to use the calculator, but we are going to start with the formula. If we were to use the calculator, this is PV. These are the payments. This is FB. And this is I by Y. Let me do this little squares so you can relate better to what we have already done. Okay? So now let's find how much is our monthly payment. Let's continue plugging all the values that we already have, and then we will change the formula to get CF. So CF is the payment which we are going to be receiving. I'm being consistent with the previous videos in which the formula of an ordinary annuity, the payments that we have in between, which are the cash flows that we receive or pay in an annuity, we refer to them as CF. So I'm being consistent here, so these are the payments. We don't know how much the payments are, so we're just going to keep CF as a variable, okay? And then we are going to plot the values here in our formula, which is going to be 1 minus, and then 1 plus I. So that is going to be 1.10 to the power of minus n. N, number of years, 5 years. So it's going to be minus 5. And then we're going to divide this by I, which is again 0.10. Once more, I think you're probably getting tired of this, but once more, we're plugging the rate as a decimal. Whereas in the calculator, we need to plug it as an integer. And then at this point, we're just going to solve these numbers and solve these formulas. So we have 10,000, we have CF, and now we can say the following. We can say this is 10,000. Then we still have CF. We don't know what CF is. But we already know that these numbers just give us 0.37908. And we still have 0.10. So cash flow times 3.79 is going to be equal to 10,000. So if we bring this number down here, okay, and I'm going to find some space to continue this. So let's do a star here, and let's continue this up here, okay? I hope it doesn't confuse you. We have 10,000. If we move this, or we divide both sides by 3.79, or we move this to the left-hand side, we will have $10,000 divided by 3.79, and we will finally have that cash flow is equal to 2,638.52. So we have our payment, and this is the magical number that we are going to get. We no longer have to wait for somebody to tell us or to hesitate before using any kind of online tool or any other tool. We already have certainty that what we are going to be charged with every month, every year in this particular case, is 2,638.52, and we did it using the formulas. So we got this number, 2,638.52. At this point, we're going to do the same calculation, but with the calculator. And we want to confirm that we are getting the exact same number. So how do we get this in the calculator? We're just going to plug the values. So what is our n? Our n is just 5 years, so we're going to plug a 5. And then our I by y is just a 10%. So in this case, because it's a calculator, we plug it as an integer. So it's 10. Now, what is our PV? Look at your timeline, and it becomes simple. You can clearly see that your PV is just the $10,000 that the bank is lending you in order to invest in your car. So we're going to plug the $10,000 here. And then we have payment. But payment is precisely what we want to find or what we want to compute. So we're just going to write a question mark here. And then FB, in the special case of any loan, FB is intended to be 0. If you're planning to fulfill your commitment with the bank, I hope you do. So by the time you reach the final period, this should be 0. So we just plug 0. So let's plug these values in the calculator. Remember to clear the memory, so second clear TVM. And now we just press 5, and then we press N, the number of years. Then we just press 10. We plug 10, which is the rate, and we're going to press I by Y. Then PV, so we're going to plug the 10,000. And I hope you get a good car with those 10,000. But we're going to write the 10,000, and then we're going to press PV. Then the payment is precisely what we are computing, so we're not plugging anything there. But in FB, we're plugging 0. You may choose not to plug anything, and that should be fine. But I advise you always to just plug 0. And then you will just press compute, payment. And at this point, you will see that the payment that we got in this calculation is exactly the same you get in the calculator. There is actually a small difference, so it is 2,637.97. This is perfectly fine since you are considering a certain number of decimals here, and the calculator is considering a different number of decimals. So the difference here is going to be less than $1. So the difference is going to be around 60 cents. That is perfectly fine. There is no issue with that. In fact, if you make sure that the calculator and your formula are always using the exact same number of decimals, you would get a perfect match. But we don't need to get concerned about that. We're going to use this as our monthly payment or as our yearly payment in this example. So at this point, we have 5 payments, and the beginning balance of our loan is going to be 10,000. So we just plug the 10,000 here. And when we do this table, you will get a very good or clear understanding on what you are doing and what the bank is doing every time you make a payment. So let's remember these are annual payments for simplicity, because I'm just going to solve 5 lines in this table and in the interest of time. But usually you're going to have monthly payments, not annual payments, okay? So you have beginning balance is 10,000, and then you have a payment. Now the interest. So the first thing you're going to get is how much you're going to be charged, how much you're going to pay, or in other words, what portion of your payment is going to be allocated to interest. So the portion of your payment that is going to interest is an expense. You're not using it to pay your loan back. You're just giving it as an expense, okay? So the amount of interest can be calculated with the 10%. So it is very straightforward. You just look at the balance of your loan and you multiply it by 10%, so you will have 1,000. Then, once you have paid the interest, everything that is left out of your payment will go to principal. Or in other words, this is the actual figure that will reduce the amount that you owe to the bank. So you will have 1,638.52. And once you reduce what goes to principal from the beginning balance, you will have an amount of 8,362.03. So I will rush this a little in the interest of time. So what is the beginning balance in the next year? This was your ending balance after you made the first payment at the end of the first year. So what is the beginning balance here? It's just the ending balance of year number 1 becomes the beginning balance of year number 2. So when you start year number 2, your remaining balance is 8,362.03. Once more, your payment will not change if let's assume that these rates are just fixed. So we're going to assume that these are fixed. If that is the case, then you will just be charged with a 10% interest again on the basis or calculated out of these 8,362.03 times 10%. So you will pay 836.20, which is going to go to interest. So once you have paid the interest corresponding to that period, everything left out of your payment will go to principal, or will go to reduce the amount that you owe to the bank or to the dealer. So out of your payment, you will have 1,801.80 that will go to your loan. Finally, you will end up with 6,560.3. The ending balance of year number 2 becomes the beginning balance of year number 3, so it's going to be 6,560.30. And again, your payment remains the same as long as the interest rate doesn't change. Your interest is again 10% out of the outstanding balance of your loan, so it's going to be 656. Once your interest is paid, whatever is left out of your payment goes to principal. So that's going to be 1,981.90. Once you pay this in principal, so you pay this out of your outstanding, you pay this to the outstanding balance of your loan, you will be left off with 4,578.30. Now, once you reach year 4, the beginning balance of year 4 is going to be your ending balance from year 3. So your beginning balance is going to be 4,578.30. Then you have the same payment, and then you calculate the 10% rate out of your outstanding balance. So it's going to be 457.8. This is going to interest, and whatever is left out of your payment goes to principal. So you will have a payment to principal of 2,180.1. So you're reducing your outstanding balance at this amount of 2,180. So you're going to be left with 2,398.2. The ending balance of the 4th year will be the beginning balance of the 5th year, so it's going to be 2,398.2. However, your payment is still the same. You might be surprised because your payment is higher than your outstanding balance, but you need to keep in mind that we have to pay interest again. So the interest is going to be the 2%, the 10% of these 2,398. So the interest payment here is going to be 239.80. Let's keep in mind you're not worried or you're not concerned about how much goes to interest, how much goes to payment when you go to the bank. It is not you that specify how much goes to one or the other. It is the bank that automatically implements this table and this amortization table and just calculates how much goes to one and how much is allocated to principal, how much is allocated to interest. The only concern of the customer is just to make the payments, and you will just make the payments if the rate is fixed, which are going to be constant throughout the life of the loan until you cancel it. Now, how much goes to principal? After you pay the interest of the outstanding balance, then you're going to be left with $2,398.2. Your outstanding balance is exactly what goes to principal. So the ending balance at the end of year 5 is 0. So you have canceled your loan, and we reach this. The magic of this is that you reach a 0 balance and you keep making the constant payments. So one interesting thing is you're charged with a 10%, but let's consider that this 10% varies because you can only be charged with an interest rate out of the outstanding balance that you owe to a bank. It would not be right to always pay $1,000 because when you reach the second year, you no longer owe the bank $10,000. So they cannot charge you $1,000 in interest. So they need to adjust how much they can charge you for the amount that you owe them, which is going to be a 10% of whatever is outstanding. In the same way, if you make any extraordinary payment to this, then you just simply reduce what is your ending balance, and then you will calculate the interest only on the outstanding balance of your loan and not on the original amount of the loan. So this is how an amortization table is prepared, and this is quite important. I hope you can get acquainted with it, know how to prepare a table like this, know how to use both the formulas and the calculator to estimate or to calculate the monthly or the yearly payments, and then what is the intuition behind beginning balance, payment, interest, principal, and the ending balance. So you're familiar with this. This is something that will be useful for you in your daily life, and it's very useful in finance as well. Thank you for your attention, and let's keep in touch.